So in this problem, we've got DC and CB. So DC is over here, and this is 4. And then CB is this length here, it's 5. But actually, it's 4 is to 5, this ratio. So you're going to write this as 4x to 5x. All right. Now, the next thing is you've got this tangent 80, and this is an important idea. This tangent 80 here is 24. It's 24. So what's the idea? If it's a tangent, then 24 squared is equal to this length squared is equal to this outside length, which is 4x, times this length, which is not 5x, it's 5 plus 4x, which is 9x. So this is your main idea. Now let's try to solve this. You've got 4 times 9 is 36. So you're going to write down 36. You've got x squared, and you've got 24 squared like this. Now you can take the square root on both sides. So you've got 24 is equal to 6x, because you're taking the square root, square root, square root. So it's much easier this way. And so x, you divide by 6, you get x is equal to 4. And that's your answer. Same problem, except this time the ratio is not 4 to 5. It's 1 to 3. So post your answers, solve this problem, and let me see if you can solve this. This is a super easy problem to solve. You're asked the center and then the radius of the circle. So what do? You take the number in front of x here, only this x. So you've got 2x, right? So you take the 2, you divide it by the number 2 and flip the sign, which means put a negative in front of it. So what do you get? You get a negative 1 here. And this is the x coordinate of the center of the circle. Now let's look at the y coordinate. The same way, you're going to take this negative 16y, because you got a y here. Just pick out the negative 16 divided by the number 2 and flip the sign. So it becomes a plus, and you've got a positive 8 here. So negative 1 and 8 are the coordinates of the center. So of course, you can eliminate this and this value, because only these two have negative 1 and 8. Now we want to find the radius of the circle. So you want to take these two numbers that we found out earlier, negative 1, and you square them. So what is negative 1 squared? It's 1. And what is 8 squared? It's equal to 64. Now what you want to do is you want to add this 1 to both sides, and then you add the 64 as well to both sides. You can ignore this left side part. You just want to think about what happens here to the right hand side. So you've got negative 49 plus 1 plus 64. That gives you 16. And this is crucial, because this is equal to the radius squared. Remember, this is very important. And so r is equal to 4. And so therefore, you've got the center negative 1, 8, and your radius. Now it's your turn. You can try to solve this problem the same way. Try to find the center first and then the radius the same way. And comment your answers. I'll be waiting. This is also an easy problem. Remember, there are two important concepts here. The first idea is you've got this particular angle here is the inscribed angle here. So what's the concept? You've got this inscribed angle is 70. Then this angle here, which is called the central angle, because this is the center, is going to be twice 70. So it's going to be 140 degrees. That's the first idea. So let's write down 140 degrees here. That's the first idea you want to remember. And the second idea is you take this 140 and you divide it by this number 360 degrees. Okay, this is your angle ratio. It's this 140 divided by the 360, which is the total turn, the total measure of the circle. And just let's simplify it. You can get rid of these zeros here. You've got 14 over 36. You can divide by 2. So you get 7 over 18. Now this is an important ratio, because to find the area of this shaded region, which is what they're asking, you multiply it by the area of the entire region, which is just pi r squared. And then what is r? Let's try to write it down. 7 over 18 times pi. R is 9. So instead of r, you just write down 9 squared like so. But 9 squared is equal to 81. And let's simplify it a little bit more. What is this? 9 times 2 is 18, and 9 times 9 is 81. So you got 7 times 9, which is 63 over 2 from here, pi. And what is 63 over 2 is 31.5. So the answer is 31.5 pi, and so this is your answer. Now you practice this problem the same way, except instead of this being 70 degrees, I'm going to make it 45 degrees. So see if you can solve this entire exact same problem. Find this area of this shaded region with this new measure and comment your answers. Let's see if you can practice and get this answer. Now in this circles problem, you're told that this EDF, this line, is a tangent to the circle. Now here's an important property. This angle here, which is between this tangent and this chord, this angle over here, it actually covers this arc. You see this arc. Also, you've got this particular angle. So if you've got, first of all, you've got this angle here that we're talking about, and you've got this other angle here. It also kind of covers this arc. So you've got this angle here, which is the tangent angle, is equal to this inscribed angle here. That's the first property you want to remember. So these two angles are the same. Now you've got another property. You've got these two lines are parallel. So if these two lines are parallel here, these two, and this is your transversal, then this angle is also equal to this angle. It's the basic idea here, alternate interior angles. So this angle is equal to this angle, and also this angle is equal to this angle. So in reality, all these three are the same. So therefore, let's think about this angle. CDF, which is over here, is equal to ACB, which is over here. And so therefore, this is your answer. Now for quick practice, find out what angle is congruent to AED, which is this angle over here. Remember, we've talked about this before. This covers this arc. So what other angle would cover this arc as well? It's one of either these, this, or one of the others. So comment your answers. I'll be waiting. This is a very easy problem. If you see a circle and you see this point, it's going to this particular value and coming back over here, then you've got this particular angle and it covers this arc here, right? But then now let's look at this easy problem. If you have these circles, if you have this circle and you have these lines here, you're coming from this point, you're going to A and you're reflecting. So you're going this way and then you're coming back here. So you see this particular value is going to cover this arc, this thing over here. So this is the inscribed angle and it covers this arc. Now, the same way how you started from B, went here and came back, you can also go this way to C and you can come back here. You see, it still covers the same arc and it's hitting C, it's reflecting and coming back. Now, any particular angle here, even this one coming back, all of these will have the same angle measure. So in other words, this value is going to be equal to this. And so you've got A is equal to C as your answer. Now for practice, see which of these angles. Now for practice, you want to find out this angle B is equal to or congruent to which other angle. Remember, it should reflect and come back here. So think about it and let me know what your answer is. Comment your answer. There's a very easy shortcut to find the answer choice here. You're asked the center, the coordinates of the center, and then the length of the radius. But what you want to do is you want to focus on the y value here, the y 12y, the coefficient in front of y. You just take the 12, you divide it by 2 and put a negative sign. So you get a -6. Now think about what they're asking. They're giving a circle and they want to find out the coordinates, the x and the y coordinates of the center. And this -6, actually the shortcut gives you the y coordinate already. Now you just want to seek out where's the -6 here. Only this answer has a -6, and so this is your answer. Now for practice, see if you can find which of these answers is going to give you. Now for practice, see if you can find out what are the coordinates of this circle. Remember, just follow the steps I told you and you'll find the answer, and comment your answers. Here we are asked what is the equation of the line tangent to the circle at A, which means a line which is tangential, and this is the point A here. What is the equation of this line? So this has two parts. The first part is to find the slope of this line, interestingly, this from the center to A. So that's very easy because you got this value -3, 4. So what's the rise? The rise is 4 and the run is -3. So you just write down 4 over -3. And so the slope is just -4 over 3 of this particular line. Now here's the second part. You want to find the equation of this line, which is tangential to the circle. Now the important thing is this line is at 90 degrees to this line. That's the second part you want to remember. So remember, this is 90 degrees. And if it's 90 degrees, then you want to know that the slope of this line is the negative reciprocal. So what's the reciprocal of this 4 over 3? It's 3 over 4. But because it's a negative, it becomes a positive. You just flip the sign. So this is the slope, and immediately you can see these two answers are out because this one has a 3 over 4. Now how do you fully write it? You're going to write this as y minus something is equal to, you put this over here, 3 over 4, and you've got x minus another thing. So what are the numbers inside here? They're going to be precisely these coordinates. Remember, this is always the x value. So let's put this -3 here and let's put this 4 over here. Negative negative makes it a positive, and so therefore you got y minus 4 is equal to 3 over 4x plus 3, and that's your answer. Now it's your turn to find the equation of this line tangent to the circle at this particular point, a 4 negative 3. So 4 negative 3 is here. Remember, you first want to find the slope of this line, then you find the tangent to this line and post your answers. So it's going to be one of these choices again. Post your answers and let's see how quickly you can solve this. This is a really easy problem to solve, and in case you're unable to see these angles inside, I've written them outside over here. So let's see how quickly we can solve this. So the most important idea you want to remember is if you've got this particular part here, this quadrilateral, this angle which is 2x over here, and this angle over here which is x plus 15. Remember, these are opposite angle. This is opposite to this, right? So then this 2x and x plus 15, you just simply add them and you set it to be equal to 180 degrees. The same way, this angle plus this angle is also going to be 180 degrees, and we're going to use this soon. But let's just simply solve this first. So 2x plus x is 3x plus 15. You subtract the 15, move it to the other side. So you get 3x is equal to 180 minus 15, which gives you 165. Now let's divide by 3 on both sides. So what do we get? We get x is equal to 165 over 3, which is 55 degrees. But is that the answer? That's not the answer, because they're asking us what is measure angle D. And measure angle D is over here. So now remember, you want to use the same method. You've got this value which is x minus, it's a minus 10 over here. So what do you do now? X minus 10 plus how much, which is D, is equal to 180 degrees. So I'll leave this problem right here. See if you can finish this problem. Try to understand why we got this, and then the answers is one of this. Obviously, it's not this answer. So comment your answers and let's move. So this is a standard angle fraction kind of a problem. You have two steps in it. The first thing is you want to find out what is this angle. Now for clarity, I've written this over here. It's the same figure over here. You just want to be clear. This is 36 degrees over here, and this length over here is 4. So it's the same figure. I've just drawn it for more clarity. So what's the first step? You've got 36 degrees over here. Now what you want to do is you want to find out this angle. So this angle is always going to be twice this angle. So what is twice 36? It's 72 degrees. So this angle or this angle, they're the same thing, is 72 degrees. Now what's your angle fraction? You divide it by 360 degrees. So this 72 over 360 in your calculator you will find is equal to 0.2. That's the first thing. Now the second step is you take this number, this fraction or this decimal here, and you multiply it by the entire area of the circle. So if you want to find out this small area, it's equal to this entire big area times 0.2. That's the main idea that you've been tested on. So what's the full area of the circle of the full circle is pi r squared. Now r is given to be 4 inches over here. This length is 4 inches over here. So you just simply replace r squared with 4. So you've got 4 squared, which is 16 pi over here. So you've got 0.2 times 16 times pi, and this value is equal to 10.1 inch squared. Check this in your calculator. Now it's your turn to solve this problem. So instead of 36, now this time let's change this to 45 degrees. Makes it a bit easier. And then this length over here, this radius is 2 inches. So post your answers below. Remember, what you want to do is you want to find out the angle fraction. You want to find this answer, and you multiply this value with the pi r squared and get your answer. Remember, practice is everything. So post your answers and let's see if you fully got it. I'm going to just start drawing what they've mentioned over here. So you've got diameter ROQ of this circle O. So you start from here and you've got diameter R. O is the center and Q is this point over here. And then they're saying the extending Q, right, to P. So you've got the point P over here. This is Q, right? Now what they're saying is tangent PA is drawn. So you've got the PA over here like this, which is the most important part, this PA. And then what they're saying is, what is the measure of this if this arc over here is 100 degrees? So let's try to solve and understand how you can solve this. So you've got this is 100, right? Now there's an easy way to kind of solve this problem, and that is to exactly draw the mirror image of this, to draw this part over here. Just copy the same thing down over here, and so you will have this part over here. So let's connect this piece and let's connect it over here like this. So you've got a nice quadrilateral over here. You've got 100 degrees here, so of course this is also 100 degrees like this. Now if these two are 100 each, so what's the total arc? It's equal to 200 degrees. That's important here. This is 200. Now if you've got this value to be 200 degrees, then this value is 200 plus how much is equal to 360 degrees. So therefore this smaller piece is 160, because 200 plus 160, it gives you 360 degrees. So of course you've got this part is 200, and then the other guy is equal to this length is equal to 160. So now how do you solve it? You subtract it and you divide it by 2. That's the formula you want to remember. So 200 minus 160 is 40 divided by 2 gives you 20 degrees. So finally you found out this value is 20 degrees. Now based off of this, how do you solve this one? It's exactly symmetric. So you divide this by 2 and you get 10 degrees as your answer. Now you try to solve this problem. This is not an easy problem. So change this to 120 degrees now. In other words, this particular value is going to be 120 degrees. If this is 120, remember you're going to replace this part. This is also going to be 120. So this part becomes 240. And then how much is this part? You want to calculate it. And then p-value is equal to 240 minus the other thing divided by 2. So post your answers in the comments. This is the way you will practice more. All right. Talk to you soon. So this problem looks quite long, but actually it's super easy. Remember, this is just the angle fraction problem. If you're able to find this angle, you can easily find the area of this sector. So how do you find the area of this measure of this angle? You want to find the measure of this angle. So let's look at how we can find that measure. You've got this particular value here, and you're also given that this is a tangent. So AB is a tangent, which means it's 90 degrees. That's an important circle property. So this is 90 degrees here. Also, you're given that OBA, which is this angle, is 36. So how would you solve this? You've got 90 plus 36 plus how much is equal to 180 degrees. So you can find this value. So basically 36 plus 54 should be equal to 90 degrees. So therefore this angle over here is 54. If this angle is 54 degrees, this angle is also 54 degrees. That's the first step of this particular problem. Now we come to the second step. So we've got 54 degrees. Now you take 54 and you find the angle fraction over here. So what's 54 over? Always divided by 360 degrees to find the angle fraction. Okay, so 54 over 360, you can do 18 times 3 and 18 times 20. So this angle fraction is 33 over 20, or you can use a calculator to get this answer. Now, what do you want to do? This is the second step. You multiply it by the area of this entire circle. Very easy to find the area of the entire circle is always pi r squared. So what is r here? The r is given to be 10. This length over here is given to be 10 OA. So just replace this with 10 squared, which is 100. So you've got this as your answer. Let's just simplify it. You've got 20 times 1 and 20 times 5. So you get 3 times 5 times pi, which gives you 15 pi as your answer. And so this is your answer. Now you try to solve this exact problem with 45 degrees over here. This OBA is 45 degrees. So see if you can solve this problem. Remember, the most important thing is you've got 45 degrees. This is 90. What is this equal to? Once you know this, find out this. Then you take the ratio, whatever that value is, you take that ratio, you take that number divided by 360. You're going to get a value. You multiply it by pi r squared, and then you're going to get your answer in terms of pi, something times pi. So post this answer in the comments and let's see if you totally understood this. This is the standard circles problem. Let's try to solve this in 2 steps. So you're given CD, which is this length here. You've given this to be 2. You're given DA over here, which is 3. And then you're given these two as 5 and 5 each. Now, anytime you see these colons here, you want to remember, you want to put an x in front of these numbers like this: 3x, 5x, and 5x. Now, here's the first important step. The sum of these, all of these arcs here around the circle should be equal to 360 degrees. So let's write it down over here. You've got 2x here plus another 3x plus the 5x plus the 5x, and that is equal to 360 degrees. Let's add them. 2 plus 3 is 5 plus another 5 plus another 5. So that gives you 15x is equal to 360 degrees. In other words, x is going to be equal to 360 divided by 15, and that value is 24 degrees. So x is equal to 24 degrees. Now, the second step of the problem comes up. So we are going to think about the second step this way. You want to find out what is the measure of angle B here. That's what they're asking. So this angle. So how do you find this? To find this angle, you first need to find the measure of this entire arc. But each of these arcs values are given because you've got 3x and 2x here. So this net part is equal to 5x. Okay, but x is equal to 24 degrees. So you write 5x, which means 5 times 24, and that gives you 120 degrees. So therefore this length is 120 degrees. And then the final step is measure of angle B is going to be equal to half of the arc. So it's half of 120 degrees, which gives you 60 degrees as your answer. Now there's an easy shortcut to this. So remember, this is 5x, this is 5x, and this is 3 plus 2x, which is 5x. So you see there's a symmetry here. This part is 5, this part is 5, and this part is also 5. So they're all basically the same. In other words, this particular part is going to be 360 degrees divided by 3, which is 120 degrees directly. So that's the easy way to do it. And then half of 120 degrees gives you 60 degrees. So that's a very fast way to find the answer. This problem here, this time I'm going to change these ratios. This is going to be 1, this is going to be 1, this is going to be 1, and this is going to be 1. So it's again symmetric, but use your logic and see and find out what is the measure of this arc using this symmetry. Remember, the total of them should be equal to 360, and then this angle should be half of the measure of this arc. So post your answers in the comments. I'm waiting to see how many of you can solve this. Let's try to solve this very easy problem. All you need to do is to find the center and the radius of the circle. So how do you find the center? The first thing is you want to move all these x and y terms to the left side, and you want to rearrange them. So let's write it down. You got x squared, and then you copy down the 6x first here, and then you've got y squared, and then you move the 6y to the left hand side, so you make it negative 6y, right, is equal to 63. Now here's the easy shortcut to finding the center of the circle. So remember, what you need is you're given a circle and you want to find the x and the y coordinates. How do you do that? You take the x value here, only the x, find the coefficient of this, which is 6 here, divided by 2, and flip the sign, so make it negative. So this value is negative 3 over here, and that actual value is the x coordinate here. Now let's try to find the y coordinate the same way. You take this value in front of y, you've got negative 6, you divide it by 2, flip the sign, because it's negative, you made it positive, and so this value 6 over 2 is equal to 3, and that's your answer. So this is the x and the y coordinates of the center of the circle. Now let's try to find the radius. To find the radius, you only need to do this. You got negative 3 comma 3 as your coordinates, right? You just square them. You take negative 3, you just square it. This 3, you square it. Now what you want to do is just add 9 to both sides over here. Plus 9 plus 9. This part you can totally disregard. Just take 63 plus 9 plus 9, which is 63 plus 18, which is 81. And this value is equal to the radius squared. This is very important to remember. And so therefore the radius is just equal to 9. So your answer is the coordinates of the center of the circle are negative 3 comma 3, and then the radius is equal to 9. And you're all set. Now it's your turn to find another answer. So you want to find the coordinates of the center and the radius the same way, but instead of this problem, you want to look at this problem. So what's the first step? You move these values to the left hand side. You're going to get a negative, then you divide it by 2 and you flip the sign. You're going to take the 8, you're going to divide by 2 and flip the sign, and this is going to be your coordinates. And then remember, what you do, you square them and add it to 5, and that value is your r squared, and then you square root it to find your r. So it'll be very impressive to see if you can solve this in less than 3 minutes, and post your comments. So let's see if you can solve it.